let us talk about what is linked list, why do we need it, how do we create it. Let us take a requirement to understand the need of linked list, and then we understand how linked list can solve our problem or satisfy our need, and then we talk about how to build it in C. You can use any language to build it, but we use C to build a linked list. Interestingly, in some of the modern languages like Java, C#, you don't have to create it yourself because the language provides library which includes a linked list. Now, the requirement is we need to take some names from user. User is going to provide some names. We have to take all those names and store them in memory. But I don't know how many names user is going to enter. He may enter 10 names, he may enter 50, he may enter 100, I don't know. And in some cases, these names come not from user but from a file, or they might be in a database. So what if they are in a file? The file may have 100 names or 1000 names, it may also have 10,000 names. So we cannot predict how many names would be there. So we cannot think of an array. Normally when we think of a collection of names, we can think of an array. But here I can't think of an array because I don't know how many elements I need to have, because that's not something I can predict. So if user is giving name ABC, we take that and we need to store it. And then if he says XYZ, we need to store that. Then he is giving PQR, we take it. He is saying DEF, we take it. And if he is giving E and D, that's like indicating the end of it. So he is saying, I'm done. I gave you all the names. Now you need to stop there. So you have to take all the names given by the user. And now at the end, you may want to print all these names. Or you may want to print only a few names where the length of the name is more than average length. Okay, or you may want to sort those names in an order. You may want to do a lot of things, but first and foremost, we want all the names to be in memory. So how do we place them in memory? To understand that, let us see what are the steps we need to take in order to have all the names in memory. So if user is giving ABC, we take that and we store it in memory, and we store it in a node. The node looks like this. In node, we have two things: the name given by the user and a pointer pointing to next node. We are going to build a list where the nodes are linked. That's the reason it's called linked list. We are also building one-way list. It can move only in one direction. But you have more sophisticated data structures like two-way linked list, where you can move either forward or backward. Or you can have circular linked list, where you can start anywhere and traverse the entire list. We are talking about a simple one-way or single linked list, where we have only one link pointing to next node. But right now this is my first node and I don't point it to anything else, so I put null there. Null indicates that's end of it. And then user is giving something like PQR and I have to store it. So I create one more node. A node is a block of memory and you need to allocate a block dynamically. So you need to ask C to provide a block of memory, and this is where you store the next value, that is PQR or whatever is given. But this node and this node must be linked. They are not right now related in any way, but I must make the first node point to second. And also the first node is the most important because only with the help of the first node I can get to second and so on. So somewhere we need to remember the location of the first node. So we have a couple of important things. There is something like root which is pointing to the very first node like this. It's all driven by pointers. The first node is to be pointed by root. Let's have some imaginary addresses. Assume this is at address 100. So we put 100 and that is what we have here. Whenever you deal with pointers, always use addresses, imaginary addresses, to make things more easy. Now the second node is at address, let us say 200, and this, the first node, should be pointing to that. So this is no longer null and this is going to point to second node. So this is where we have a pointer pointing to this. So does it mean we store 200 there? Yes, that's what we are storing. So there you are talking about address 200, means it is a pointer. So what I have in each node, a string to store the name and a pointer pointing to next node. But this is the last node, so we are going to have null for now. Then user is saying he wants to give XYZ. Remember, this is the input given by the user. So user is giving XYZ and I create one more node somewhere in the memory. It doesn't matter where it is in memory. Okay, it doesn't matter where the node is in memory. We have it and we have the address like 400. And that address is now to be copied into this, and you have to link them properly like this. So there you put the address 400 and this is not pointing to anything else. Like this you keep on building your list. You can take any number of names and one name at a time is taken, a block is created, and in the block we place that name and we make the block point to the next one. If it is last one, it points to nothing, otherwise it points to next one. And the most important of all these blocks is the first one and its address, because if you don't get there, you cannot access the rest. So if you lose that root, the address of the first node, then the whole list is gone. And you need to make sure you manipulate these addresses carefully. A small mistake will break the link and your list is gone. And it's little sensitive because it involves pointers and you have to be double checking what you're doing, because it's easy to make silly mistake and pay high price. And you've been working with C for quite some time and you know C does not bother to check your mistakes. Because C has a philosophy, programmer knows what he's doing. But more often beginners don't know what they're doing. Then they run into all kinds of problems. And this is an area where things are much more sensitive, so you got to be more careful. Now this is a linked list. It's not really difficult, but at the same time it's not as easy as drawing the diagrams. Building a linked list takes little effort, so we will build it, we write the code. But first I want you to understand what a linked list is, how does it look like. And once the user says after all the names E is done by giving E and D, you're going to stop it. And by the time you stop, you already have this route pointing to first, first points to second, second points to third, third points to nothing. So we got the list. Okay? And this is the way your list goes. Now, compared with arrays, what are the major advantages of linked list? This is a common question. In what way linked list is better than array? In what way it is inferior to array? There are some pros of arrays, some cons of linked list as well. But if you consider the requirement where we take names from user, we don't know how many names user will enter. He might enter 10 names, 20,000, 10,000, we don't know. All the names are to be stored in memory. Array cannot be created for unknown number of elements. So the first major advantage of linked list is you do not have to decide the size well in advance. For array, you have to decide the size at the time of creating the array. But for linked list, you don't have to do that. Keep taking the names, keep adding them to list, and it can grow to any extent. The only limit is your memory. You can have as many as your memory can accommodate. So it can grow dynamically. It can grow as much as you want. An array cannot be dynamic. Once you create an array of 10 elements, it can accommodate only 10 elements. It cannot be anything bigger than that. Now, the other advantage with the linked list, though not important in our context, you can easily add a new node in between existing nodes. If I need to add a new node, say I want something in between ABC and PQR. For some reasons I want to put something in between these two. Then you can easily do that. In case of array, remember, you have to push all the elements to right to accommodate a new element in the middle. But in linked list, we don't need to do that. For example, I am having a new node somewhere in the memory. This is my node, and let us say I have the value DEF. I want that to be between ABC and PQR. All that you need to do is manipulate just 2 pointers. You have to now say this is no longer pointing to PQR, it is pointing to this. Okay, it is pointing to this, and let us say this is at address 500. So we put 500 there. Now if you leave it like that, it's a disaster because the link is broken. And what you need to do is make sure this points to what this was pointing to. So now this has to point to 200 because that's what your 100, this node was pointing to. So create a block, put the data, and change 2 pointers, only 2 pointers, and you got a new node inserted in between existing nodes. When we do large scale data manipulations, every performance improvement is important because every inefficiency is magnified and every efficiency is also magnified. So you have to make sure everything is as efficient as possible. And moving say some 1000 elements to the right involves lot of memory movement. But manipulating just 2 addresses and having a block is so simple. You don't need to do much. So comparing this with array, a linked list is far better and it is more efficient when it comes to insertion. Moreover, in array insertion might not be possible at all. In array insertion might not be possible if you fill all elements. But in linked list insertion is always possible. So, do you understand how we are going to add a new node in between existing nodes? The next thing, how do we delete an existing node? It's possible to delete a node, and we can delete a node as easily as we inserted. Let us assume we have to delete this 200, this PQR. Then I need to know what is the node I want to delete, and I must know the previous node. I must have access to previous node. So once I have access to previous node, which is 500 here, now all that I need to do is make this pointing to what this is pointing. One simple operation. So all that I need to do is I need to go and remove this and make this pointing to what this is pointing. That means I just need to put 400 there. It means this is pointing to this. And it might be there, but that is irrelevant. We don't bother about that. Now this link is gone. We are not pointing to this. So automatically this node is no longer accessible, because from root we go to 100, from there 500, from 500 we go to 400, and we are not going to this. And this is delinked, this is gone, and now we can release it from memory as well. We can release this block from memory. We have functions to deallocate memory, and if you are not deallocating memory, you will end up consuming memory with unused blocks. If you are dealing with large scale data, if you are talking about thousands of nodes, if you leave a lot of nodes in memory, they are all unused, but still they consume space. And this is like you're keeping a lot of books on your desk that are not needed. Then do you have space for books that you need? Not at all. So as and when you don't need a book, you have to remove it. Now here is the node that we removed from the list with one simple operation. But those operations must be done accurately. Any small deviation is going to cost you very dearly. Now this is a simple one-way linked list. But we start with simple one-way, and then you can think of a two-way where everything will be done in 2 pointers. This is only pointing to next node. We can have a previous pointer which points to previous node also. The advantage, you can move in both directions. Now the advantage or disadvantage with this is I can only move in one direction. So arrays and linked list, that's the general comparison. Number one advantage with the linked list, you can have as many elements as you want. You don't need to know it well in advance. For array, you must know the number of elements well in advance. Number two, insertions are easy. Number three, deletions are easy. And number four, the nodes can be anywhere in the memory, even if your memory is highly fragmented. even if your memory is highly fragmented, that means you don't have a single large block of memory, you have many small pieces of memory. It's like you have a lot of land but in small pieces. You don't have a single large land of 100 acres that you want. Instead you have 10 acres in one place, 15 another place, 13 another place, scattered, fragmented. But linked list doesn't mind that because it needs only small blocks of memory. But if you are talking about an array, remember an array needs a large contiguous block. Array has to be in one place. The whole array should be in one place, whereas in case of linked list, we have small nodes which can be scattered all around. Then, of course, array does have two advantages over linked list. Number one, arrays provide random access. You can access any element in the array. You can't do that with linked list. So no random access for linked list. We have random access for array. And another advantage with array, it's simple. It's simple to create an array. It is simple to use it. You don't need to worry about any algorithms. It's all easy. And ease of programming is always an advantage. But as we discussed, array does not fit into our requirement. We cannot go with an array because we don't know how many names we need to store. So a linked list is a better bet and best suited for many cases. So let us see how we convert this whole thing to a program. So this is about how your linked list looks like. So if I look at a particular node, there are two things in the node. One, a string, that's data. In my simple example, it's a string, but it could be any amount of data you want to store. It might be the details of student. It might be all the details of a product or employee, anything you like. It can be as complex as you want. And the address of the next node. So two things are to be put together, or you may have many things in data plus the address. So when I have to do something like that, we have to go for something like a structure. You know, structure is the way to store multiple members together. So if you want to create a node, first you need to declare a structure for that. So let us build our application step by step. So I start an empty file and we are building a linked list. So this is about a linked list of names, and don't need to copy anything. I'll make everything available in our GitHub. Now to start with, we need to deal with a few includes, and then we are talking about a structure. Struct node we call it. We typically call it as a node because it is the terminology, and the node contains just a string, that is the name. I say it can have up to 20 characters. And then interestingly, it needs a pointer to next node. That is my structure. Now we have a structure where I have an array of 20 characters plus a pointer. All that you need to know is you need a pointer, and we have seen pointer always occupies say 4 bytes. whether it points to structure or an integer or a double. So I'm creating a structure. The speciality of the structure is a pointer in the structure is of the same type. Such structures are also known as self-referential structures. They refer to themselves. So this is my structure, and we will be building the rest of the code, but for that I need to have some variables, or rather pointers. So I start my main, and I need at least 3 pointers to build the list. So I say struct node pointer called root, then current and previous. I need 3. As I write the code, you understand why I need them and what is the purpose of each pointer. But the root pointer is going to initially point to null. Remember, null is nothing but 0, but null is coming from that stdio.h. It's actually hash defined. In stdio.h we have hash defined setting null to 0. So root is set to null. We are saying we don't have anything right now. Then we get into an infinite loop while 1. This is a never ending loop. Is it? While 1. And then we want to take name from user. So printf enter a name, and then we take the name, get as name, and we need to declare that variable character name of 20. And after taking the name, the first thing I want to do is see whether name is END. If name is END, we stop. We don't do anything. So strcmp name comma END. If it is returning 0, then I stop. That's all. I don't do anything else because it indicates user doesn't want to proceed. Otherwise, we got a name, and the first thing we need to do is create a node. What do you mean by node? A block of memory where I can store name and address of the next node. Creating a node means creating something like this. This is what I'm planning to create. And to create the node, we need to get a block of memory, and this is called dynamic memory allocation. So this is called as the dynamic memory allocation. So we need to go and do that. So I say give me a block of memory, and the size of the block is going to be the size of the struct node. This is how I'm asking for a block of memory. This is how I'm asking for a block of memory. And once we got the block of memory, you got to point to that. Okay, you have to point to the block because malloc gives you the block and address of the block. So it's like I'm creating a block in memory, and I give you the address of the block so that you can point to that block. So how do we store pointers? Using pointer. How do we store the address? Using pointer. So current is now pointing to this block's address. But there is one more formality. This malloc is saying, I give you a pointer, but I don't know to which the pointer points. It will give you a raw address. But we have to say this raw address is pointing to a struct node. Because remember, a pointer should point to some data type. It should either point to an integer or float or character and so on. So we need to do what is called as typecasting. So I say, okay, I take the block I take the address of the block and I convert that to struct node pointer. This typecasting is needed because malloc does not know what you have or what you want to have at that block, in memory. So you're saying I want to treat that as struct node, so we want that to be converted to struct node pointer. And then what is the next step? It's like you got a new block in memory. Once you got a new block, there are two steps. Step 1, put the data. Step 2, make sure this is null, because this is the last node. There is nothing after that. So let's do that. I say current of name. Do you remember arrow operator? Arrow operator is used when we deal with a pointer to structure. strcpy this comma name. So copy the name, copy name into node. Then the node should be pointing to nothing. The next of it is set to null. Null in uppercase, okay? Okay, make next point to nothing. As this is the last node, that must be there. But now, how do you link this node with the list? It is last node, but there might be some nodes before that, right? And that previous node should point to that if there is a node. But if there is no previous node, if this is the first node, there is nothing like previous node. In that case, I don't have to do anything. Two things. If this is first node, make root point to this. But if this is second node, make the previous point to this. Once again, if this is first node, make the root pointer point to this. But if it is not the first node, there is a node before that. For example, I'm creating a node like this. I already have a node before this. Then make the previous node point to this. So either you make root point to it, or you have to make the previous node point to this. One of those two must be done. But how can I know whether this is first node or not? Well, I can, because if root is equivalent to null, that means we are dealing with the first node. If root is pointing to nothing, that means the node we created is the first node. So we say root is equal to current. Otherwise, you have to say the previous of next should be the current node. Previous of next should be current. But what is previous? That is pointing to the previous node. Now this is the process. But one last step before we leave the loop is what is current now should become previous for the next iteration. Whatever is current now, that should become previous for the next round. So it's very important to say your previous is current. So make current previous for next round. In the next iteration, what you think is current now should become previous. This is very crucial. When you don't do such things, you will run into bugs because you are using previous. And nowhere I'm assigning anything to previous. So previous will have a junk address. And you are trying to put something using that address somewhere. That's a disaster. A small omission can make a lot of difference. And this is the easiest of linked lists. This is the easiest of data structures topic. And you have two-way linked list, circular linked list, trees, binary trees, they're all much more complicated. But do remember, without data structures like this, no application, no quality application can be developed. So all your softwares like your database systems, your operating systems and lot more use data structures extensively. That's the reason why companies like Google, Apple, Microsoft in their recruiting process stress more on data structures. Most of the selection procedures are related to your knowledge about algorithms and data structures. Algorithms like what are the steps you need to take. So they ask you if you have to insert a node into a doubly linked list, what are the steps you take. Sometimes you have to on the spot write those steps to prove yes you know what algorithm you need to apply. Well, in fact, this is done if the input is END we stop, and if it is not we create a node, make the name, copy the name into that node's name. This is like putting data. Then make that node point to nothing. But if it is the first node, do it. If it is not the first node, make previous node point to this node. That's what you need to do. The previous node should be pointing to this. So by the time I'm here, I have the whole list in the order. And where is the beginning of that list? The beginning of the list is here in root. Your root is supposed to point to the very beginning of the list. So if I say print list, I have to start like this. Current is equal to root. Never change root. Okay? If you change root, you lose the beginning of the list. If you try to change root to something else, it's gone. The beginning of the list is lost. Now while current is not equivalent to null, if it is not null, I want to print the name. I say put as current of name. This is the way we print it. And then we need to move to next node. So current is equal to current of next. And if you just keep doing it, you keep moving forward until you reach null. When current of next is null, then current is null. When current is null, you are going to terminate the loop. It's as simple as that. And I just want to save it. I say linked list, and then I think we got everything right, and I just go and build it, and it is coming back without any red blocks. That means all is well, and then you need to run it. So before you run, you need to pray that everything would be fine. Okay? And you need to keep your fingers crossed. Well, this is a small program and it is written by me, so you can relax and say yes, it works. But when you create it on your own, when you do it on your own, and when you try to do something different from very elementary stuff, well, there is always a possibility of something going wrong. Don't get disappointed. Don't panic. That's very common when you deal with data structures. You do hit roadblock a few times. Now go ahead, run. It's asking for names. So let's give some big names. Bill, Larry, Dale, Jobs, Musk, and then Mark. You know all these names, right? And then END. That's not the name. This is where we stop. And now, the moment of the truth. So, if I press enter key, if you are getting all the names, it means your list is perfect. So, this is the way you're building a linked list. And this is how you have to create nodes, and this is how you take input from user. But as I told you, this might be replaced with you reading lines from a file. The data might be coming from lines from a file. Now what I do is I don't disrupt this. I'll show you one more version. It's not about a new structure, a new linked list, but just a new requirement. So let us save this as something else, and I just call it as long names, because I'm going to display the names that are bigger than average length of names. I would like to display only those names which are having length greater than average length. Now it's going to be the same. I just need to here find out what is the length of each and every name and add that after you take this here, much before you create the list. This is where we are going to add that to total. So I say total plus is equal to strlen of name. And also we need to keep track of count. When you talk about the average, you need to have two things, total and count. Now we need to create both these variables, so I create them here. Int count is equal to 0 and total is also 0. And that is what I do. And also I go for average, and it is not set to anything for now. But once the list is completed, this is where I'm going to calculate average is equal to total by count. It's all integer calculation. That's okay. We are just going with all integers. If you want, you can think of floats. But anyway, the length is integer, so we go with integer. Now this is where we got the average length of names. But now I don't display all the names. I display only the names where the length is more than average length. So print names that have length more than average length. So we have to just make a minor adjustment here. Just a small if strlen of current of name. If the name length is greater than or equivalent to average, then you print, otherwise don't. Small change. Right at the time of you building the list, you are calculating the average, and now at the end when you are printing, you don't print all names. You print only those names where the length is greater than average length. So say build and then run. So this time we talk about job, then Johnson, and I'm talking about Steve and Scott, Ben, King, END. So you get some names, and suddenly Johnson is displayed. And what about Steve and Scott? Are they displayed? We'll see. There we are. So they're all being displayed. But you don't get job, Ben, because the average is something that is probably 3, I don't know, or might be 4. And we are getting all the names where the length is greater than or equivalent to average. And a lot more can be done. There is no limit. In fact, for many requirements, there is no alternative but linked list. Without linked list, you just cannot accomplish the task. So there are a lot of things that you need to focus on when it comes to this. The same as previous program, the only difference is you have some more code to calculate the average and display only those names that are having length greater than or equivalent to average. So this is the way we can change our requirements, get the job done.